Welcome to video 4 for this unit on introducing exponential functions. In this video, we're going to focus on percent growth and decay. When we borrow money from a lender, the lender usually charges interest, a percentage of the borrowed amount, as payment for allowing us to use the money. Suppose you received a loan of $500 and the interest rate is 15% calculated at the end of each year. If you make no other purchases or payments, the amount owed after 1 year would be 500 plus 500 times 0.15, or 500 times the quantity 1 plus 0.15. The amount owed after 2 years would increase by another 15%. The table shows the calculation of the amount owed for the first 3 years. With no further purchases or payments, after T years, the debt in dollars is given by the expression 500 times 1.15 to the T. Compounding is applying a percent increase on an amount that has had a prior percent increase. Compounding happens when we calculate interest on money in a bank account or on a loan. An account that earns 0.5% interest every month does not actually earn 6% a year. Suppose a savings account has $1,000 and no other deposits or withdrawals are made. The account balances after some months are shown in this table. $1.005 to the power of 12 is about 1.0617, so the account will grow by about 6.17% in 1 year. This rate is called the effective interest rate. It reflects how the account balance actually changes after 1 year. Let's look at the same bank account with the balance of $1,000 and a nominal annual interest rate of 6% per year. No additional deposits or withdrawals have been made. If the bank compounds interest annually, the account will have one interest calculation in 1 year at a 6% rate. After 1 year, the account balance will be 1,000 times 1.06, or $1,060. If the bank compounds interest every 6 months, the account will see 2 interest calculations in 1 year at a 3% rate each time, because 6 divided by 2 is 3. The account balance in 1 year will be 1,000 times 1.03 squared, or $1,060.90. If it is compounded every 3 months, there will be 4 calculations at 1.5% each time. The account balance after 1 year will be 1,000 times 1.015 to the 4th, or $1,061.36. We already saw that if the account is compounded every month, it will have 12 interest calculations at 0.5%. with an account balance after 1 year of 1,000 times 1.005 to the 12th, or $1,061.68. Notice that the more frequently interest is compounded, the greater the balance is. In an exponential function, the growth rate is the fraction or percentage of the output that gets added every time the input is increased by 1. Suppose the area, represented by A, covered by a forest, is currently 50 square miles, and it is growing by 0.2% each year. If T represents time from now in years, we can express the area of the forest as A equals 50 times 1.002 to the T. In this situation, the growth rate is 0.002. and the growth factor is 1.002. Since 0.002 is such a small number, it may be difficult to tell from this function how quickly the forest is growing. We may find it more helpful to measure the growth every century. There are 100 years in a century. So to find the growth rate in centuries, we can use the expression 1.002 to the 100th, which is about 1.22. This means a growth rate of about 22% per century. Using C for time in centuries, the area of the forest can be expressed as A equals 50 times 1.22 to the C. Thank you for watching video 4 of 4 for this unit on introducing exponential functions.